Good evening, student. How are you? I hope you are good, taking care of yourself. Is the screen is visible to you? Am I audible to you? If yes, please put the message in the chat box. Okay. So, firstly, let me ask you one question: that how is your day? Is it fine? Very good. What have you done today? Study, sports, music. Good evening to all. So, you have enjoyed today's hours that is allotted you by nature classes. Okay, so classes are being nice, that is why you have written that your day was nice, huh? Got it. How many classes do you attend in a day? How many classes are there? Like for theory only? I think physics, chemistry, mathematics, and Hindi. Do you study Hindi? I don't think so. If you are from CBSE board, that Hindi will not be in your syllabus. Any optional subject. So 8 classes a day you will take. And what is the length of one class? I guess it is 45 minutes, because usually it will be okay, 35 minutes. Got it. 35 into 8, I think it will become 8 5 40 0 8 3 is 24, 280 minute approximate, है ना? Which becomes approximately 5 hours. Okay, so do not, it's not a big time that you have spent in the school. 5 hours is, I think, is adjustable, because in a day you will get at least 16 hour. Okay, 7:45 to 1:30. That is not a big issue. That is, I think, bearable. You guys are young and has a tolerance. So 7:45 to 1:30 is just a good to go. After that, you will take your, I think you will take your lunch, and then you will move on to, if you have opt for sports, you will play some sport, then you do some homework that is provided by your teachers. And then finally, from, I think, from 3 p.m. onward, you have the classes. So from Avanti fellows, huh? 3 to 6 Avanti. Got it. Which means 3 hours you will dedicate to your dream, which is full 5 by Avanti fellows. Like dream to become an engineer, become a doctor, or to study from a prestigious institute. Okay. 6 to 7:30 you will do evening study. Got it. So do you need, don't you get any break in between then? Because just after 6 p.m. you need to sit back for your study, huh? So if you are getting break, okay. 8:30 to 10:30 self study. Good. But try to remember to take break, huh? Because if you study without taking break, so there will be a mental fatigue arises. Okay, and that will not good for your health, especially for your mental health. So if you or released that after this session you will released at 6 p.m. So try to take break for at least 10 minutes or 15 minutes, then start your study. Okay, and do it for every hour. Like after every hour of completion of your study, take at least 5 to 10 minutes of break, and then refresh, and then freshly start your day. Okay, your next hour. So it will help you to reduce your mental fatigue and improve your overall muscle memory and mind memory. Okay. Okay, so it was nice talking you. Let now we are focusing on our curriculum, which is we have just completed the oscillation chapter. You might be thinking that on oscillation we don't have study about the spring mass system and all. So don't worry about that. We will cover that with the question approach, with the numerical approach in weekend classes. So try to attend and make sure that you will be there in the weekend classes, because we were doing great questions in that classes in the upcoming class. I think one class I will give to the thermal properties of matter. Some of the question we will select, and then the later on classes will be on oscillation purely, and we will discuss some of the good questions, and even advanced question will be there, and question solving approach will be discussed there. So try to be attentive in that class also. Okay, it's for the goodness of yours, because these exams are just not only the theory exam that you will just learn the theory and get the answer. No, these are the numerical approach exam. So how many questions you have solved, that will depend, and that on which depend the success of yours. Okay, your success entirely and totally depend on the number of questions that you have attempted correctly before the exam and in the exam. Okay, so this is the alignment of chapter oscillation. So in this chapter we will mainly focused on the wave. Okay, so firstly this chapter that has been written in your Avanti not textbook is wave on a string, but this entire chapter will be covered as wave mechanics. Okay, so if you find out the JE syllabus, in that syllabus also you will find this chapter to be oscillation and wave. Okay, so we will be do that in two parts. Wave on a string, we will characterize the wave, how the wave will form, what is the equation of wave, what are the key terms in wave, and how to solve a question related to wave equation. Then in part 2 we will be dealing the practical waves like sound wave, and we will discuss all about all the phenomena related to that sound wave, and including Doppler effect also. Okay, so this is our lecture number 1, wave on a string. So let's just get started with it. Now the very first thing that you are going to, this is the total weightage of this chapter: wave motion, principle of superposition, that will help you in all. Okay, principle of superposition, this will also help you in your 12th class when you will deal wave optics. So this principle of superposition, that will help you there also. Then reflection of wave. Okay, how the wave reflect from rigid boundary, from fixed boundary, or from flexible boundaries, and what is the nature of that reflection, that will be covered in this part, reflection of waves. Then we will deal the standing wave and normal modes. The standing wave means like the wave on a string when the both the ends are fixed, and if you stretch it from the middle portion, you will get a shape like this, very fastly oscillating about this position. So these wave which is not going anywhere, but still the particle in oscillatory motion, these types of wave are standing wave. We will deal how to solve how to form the equation and what is that. in standing wave and normal modes also. Then we will deal the beats, that is actually the difference of two sounds, and then finally we will discuss the Doppler effect. But this is not that we are going to cover today only. Okay, this is the entire syllabus of wave mechanics, you will say, or waves specifically. Okay, now if I talk about the very general information from you guys, every day we use wave in one form of another. So these, everyone got the alarm clock, either the physical one or the inbuilt that is in your smartphone. So what are those? This produces a sound, and sound is considered to be a wave. Okay, so we will deal these wave phenomena in our daily life. This is the sound wave. Also, if you watch television, then the antenna on your household or at your GNV, if some antenna was there, I don't think so that antenna will be here now. Is the time shifted to dish TVs like this one. So these also receive some kind of wave, okay, some kind of energies, and they will transmit to your TV or whatever you are watching. Okay, or if you are listening to radios, they are mentioned in the radio, the name of the radio station, that it is at 90 megahertz or 130 megahertz. So these megahertz, we know it is the measurement of frequency, and frequency is associated to wave. So we will deal in our daily life, we mostly in the field of wave. Okay, the most basic wave that you have seen when you have water in certain water pond, if you drop a stone, so it will generate the ripples in the water. So these are also the wave. Okay. Now what is a wave? That will be answered in the next slide. Okay, now from here we can sometime we can guess something. We can guess that wave is something which is traveling to us, or which is traveling from one point to another. If you talk about this alarm clock, that something is travel to your ear. Okay, and that something is nothing but sound. If you talk about this radio waves, so these radio waves contains the programs, the TV shows, and the different channels. Okay, these are traveling to your TV from one place to another place. If you talk about this light waves, so these light waves are traveling, carrying something like in pictures or the scenes from one place to another place, and that another place is your eyes. So at least we can guess that wave is something which is traveling from one place to another. Now what is this something? Now we will answer it in the next slide. Okay, so a wave is a disturbance that transfer energy from place to place. So that's something we are talking about, is something is energy. Okay, so this is very clear now that wave is a kind of disturbance, is a kind of disturbance which is traveling from one place to another place, and that disturbance is energy, the transfer of energy. Okay, now I think wave, the definition of wave is clear to you guys. Okay, this one, if you look at this one, this you can consider a string. Okay, if we give, if we disturb the position of this one, like if you will see this, we have disturbed the position of this ball here, and these all the balls are attached to one another with the help of a string. So what we will see, we are seeing that if we disturb one, that disturbance is traveling from one place to another place. Got it? which means it is forming a wave in which the disturbance is traveling from one place to another place. So this is nothing but a wave pulse. Got it? One thing is very important to note here. If you will see carefully, the particle is not moving with the disturbance. If you focus on this green dot, this one, it is at is where it is. Okay. Initially, it is at this position. Okay. Finally, it is at this position, but the disturbance has traveled further. So in wave, there is, we can say, only the disturbances travel from one place to another place, not the particle or not the medium. Okay, got it? Now, if we move to the next, so this is important. The wave is passed from left to right here, from particle to particle, but particle did not move from left to right. Particle only move from up to down. Okay, up and down. So this is important thing to note here that I have already discussed with you. Got it? Now, if you will see, if we continue this, if we continue this disturbance, then a proper wave we have got. And in this also you will see that particle is not traveling from one place to another, or you will see in this way, because disturbance is traveling from left to right, and the particle itself, if you focus on this green dot only, this one, the particle is traveling from up and down. And this up and down kind of motion, you can say it is a bounded motion about this position. And we have studied recently that a bounded motion about a point, and that is to and fro kind of motion, is termed as oscillation or oscillatory motion. So in wave motion, the particle itself in the oscillatory motion. Got it? And if we combined all the oscillatory motion of each and every particle in the medium, the final picture we got is the oscillation, or is the wave. Okay, got it? Any kind of doubt in this? We are discussing it thoroughly. Okay, if you have any kind of doubt, you can ask. Now, the important thing to note here that wave is traveling from left to right, but the particle is not. Okay, particle is traveling up and down in a oscillatory motion. Got it? This is the particle motion, and this is the energy which is traveling, or disturbance, you can say. Okay, so from that we can say if particle is not transferred from one place to another, only the disturbance or the energy, so we can say that wave only transfer the disturbance, not the mass. This is important key fact, this one. Now wave motion, I think it is clear to you that what is a wave and what is the disturbance we are talking about. Okay, now wave motion may we have to discuss what is the types of wave, propagation of wave. Propagation means movement of wave. The wave movement we will discuss, and propagation we have used a specific term which is propagation, how the wave is propagate in one medium to another. Then we finally describe it by equation, mathematically developed equation of waves. Then basic term in waves, speed of transverse wave and speed of sound wave. You will wondering what is transfer wave. Transverse wave we will discuss in the types of wave. Okay. So this thing we need to discuss today. Not today, but one by one. So types of wave firstly we will discuss. So there are three types of wave firstly we will have. Okay. And it will depends on the types of situation that you will take. So here, the types of waves that we are going to discuss is according to the medium for propagation. In what medium they are propagating. Based on that, We have three types of wave: mechanical wave, electromagnetic wave, and matter wave. Okay, what three kind of wave we have? Mechanical wave, electromagnetic wave, and matter wave. And this will according to the medium of propagation in which the wave disturbance is traveling, that traveling medium. Based on that, we have three kind of wave: mechanical waves, electromagnetic waves, and matter wave. Well, what is mechanical wave? Which requires a medium, that is mechanical wave. M for medium, M for mechanical. Which does not require any medium to travel or propagate, is termed as electromagnetic wave. And matter wave is associated to the matter only. Okay, specific mass like electron, proton, neutron, they always possesses their waves in terms of photons and all. So that we will take as electromagnetic, matter wave. So firstly, mechanical wave. So these waves require a medium to travel and cannot travel in vacuum. Why? Because vacuum does not have any medium in itself. Okay. Vacuum means absence of medium. Got it? So that is why mechanical wave is not possible in vacuum. It is only possible in a certain medium. Okay, because it required medium to travel. For example, wave on a string. Why wave on a string? Because a string, the material of a string itself is behaving as medium. Wave on water surface. So these are form on water. The medium is water. Sound wave. Sound is formed in air, and the seismic wave or seismic wave you can say, which is the which is formed by the to and fro kind of motion of plates of earth. Okay, seismic plates, we have earth that will responsible for the earthquake. Okay, so these are those waves. Now, for example, this is the wave in string. Just a second. This is the wave in string. This is the water ripple form. Drop by drop is falling in this pond, and these are the water ripples form. Okay, and these are the seismic wave. Got it? So the key point to note from mechanical wave is that it required a medium to travel, and second, they cannot travel in vacuum. Now the electromagnetic wave, so these wave does not require any medium to propagate. Okay, so do not need a medium to propagate. And the second thing that we can say, it can travel through anything, be it be solid, air, or solid material or vacuum. That is why we are able to get the light from sun. Because if you talk about sun and earth, there is no medium in between them. Although there is vacuum filled, okay, in space, there is no air. A vacuum will be there. So if a wave require a medium, then how this light is traveling through earth? So these light waves are different kind of wave, which is electromagnetic wave. They does not require any medium to propagate. So that is why they are able to propagate through vacuum also. Got it? So this electromagnetic waves means we have a variation of electric field and magnetic field. These you have to remember. Okay. Now matter wave. So matter wave are associated, I have told you that they are associated with the constituent of matters like electron, proton, neutron, and atom and nucleus. Okay. So they arise in quantum mechanical description of nature that you will learn in your later studies if you do so. So the key fact here to note it down that matter wave are associated to the constituent of matter, that is electron, proton, and neutron. Okay. Now nature of wave. So there are two types of nature of wave. First is longitudinal wave and second is transfer wave. Before that, what we have studied? We have studied the types of wave. So types of wave, we have three types of wave: electromagnetic wave, mechanical wave, or matter wave. Now the nature of wave. Nature of wave, we have two types: longitudinal waves and transverse wave. Now we will discuss them one by one. If you will see here, in this transverse wave, why we have specifically assigned the name transverse to it? So the shape that you will getting here is like this. Okay. So if we will focus, the wave is traveling in this direction. The disturbance is traveling in this direction. But the particle, if you focus, they are traveling, or they are propagating perpendicular to the wave motion. They are traveling up and down, which is perpendicular to the wave motion, because wave is traveling from left to right and they are traveling up and down. So they are traveling perpendicular to the wave motion. So that kind of wave we termed as a transverse wave. The same wave, when you grip a string, grip some kind of string, and tie it one of one end, and give a pulse to it. So that wave is also the transverse wave, because wave motion is in this direction, from left to right, but the oscillation of these particles, or this particle of that medium, is oscillating perpendicular to the wave. Okay, perpendicular to the direction of wave motion. But in longitudinal, if you will see, in longitudinal, if wave is traveling in this way, left to right, the particle will also oscillate oscillate in same direction. Same direction. Got it? This is the key difference in transverse wave and longitudinal wave. Now, if we talk about longitudinal wave, I hope you got it till now. Any kind of doubt? Student of JNV Ramnagar? Any kind of doubt you are getting? Tell me. Is this clear now? Till now? What we have discussed? Tell me. Okay. So longitudinal wave, now, as I have discussed, that the particle motion is parallel to the direction of propagation of wave. Okay. So that kind of waves is termed as longitudinal wave. This one. So if you see this piston, or here we have some air, these you can say the air particles. So when these piston move rapidly, these particles came closer to each one, and this pulse is formed here. Got it? So we can say the particle is also traveling in the direction of wave motion. If you focus on these red dots are the particle. They are oscillating in the direction of wave motion. Okay. So these kind of wave we can say is the longitudinal wave. Our sound wave is the example of this longitudinal wave. Now what is compression and rarefaction? So the forward motion of particle, when we push it in the forward direction, so these molecule create a high pressure here. Okay, because these molecules come closer to each other, that is why the pressure of the system will rise up. So this is known as the compression, because we have compressed the particle. And how it is possible for air? Because we move so rapidly, the piston is moved so rapidly, so the particle will not get time to attain that kind of motion. So they will align one, they will compressed, because if they are not getting time to move with piston, so they will get compressed. So there is a compression will form, which is of high pressure. Okay. So that is why this phenomena, this black color lines, if you will see these, this one, which is traveling, these are the compressions. Okay. But if you, when the piston is moved backward, although in the same time the particle will not get so much time because of the inertia, so they will be separated from their particles, their aligned particles. So these separation between two compression is termed as rarefaction, where we have a low pressure value. Okay. So the backward retraction of the particle creates a low pressure area, allowing the particle to move back to the left. This is known as rarefaction. So rarefaction is the zone of low pressure and compression is the zone of high pressure. Okay. Also, if you understand this phenomena in terms of density, so density we have mass by volume. If we will see this compression, so due to this compression, these all the particles is sum up in this small volume, this small volume. So we can say the mass is increased and volume is decreased. So density will increase. Got it? And if you talk about this rarefaction, so we have number of mass particle, the number of particles is lesser than the compression one. So if number of particle is less and volume is high, you will see this volume is high. So we can say in density for rarefaction, mass is get lowers, volume is get high, so density will decrease. So low density in the rarefaction. Instead of pressure, you can also learn that a compression is nothing but a zone of high density and rarefaction is a zone of low density. Got it? Now, move on to the next one. Now, if you remember, we have talked about the stresses in the mechanical properties of solid. What does the stress mean? Stress means the force applied perpendicular to the area. Now, if you will see, these particle is compressing the particle adjacent to it. Let's say these are the particles and this is piston. So these particles, and let's say these are another particles. So this particle which is attached with the piston is somehow compressing these particles. Okay. And this compressive force is perpendicular to this cross-sectional area. If you talk about this area. So this compressive force is perpendicular to this area. So it is satisfying our condition. So here we will have a compressive strain. Compressive stress. So if in any medium there is no chance of developing compressive stress, there will be no formation of longitudinal wave in there. Okay. Because if compressive stress is there, it will obviously causing some of the compressive strain. Got it? And you will see initially the particle is at this separation. Finally, they are at this separation. So the length is reduced. The original length and final length has a difference. So this will cause up the strain. And this strain is caused by the compression of the particle. So that is why this strain is termed as compressive strain. Now let's say if any system or any medium does not have a kind of compressive strain, then what will you say? This particle does not sustain any kind of longitudinal wave. Okay. I hope you got it. The concept of compressive strain. Okay. So both fluid and solid can sustain the compressive strength. So thereby, this longitudinal wave can be propagated in all elastic media, whether it is solid or whether it is fluid. And by fluid, what does we mean? We mean liquid and gas, both liquid and gas. That is why our sound can travel into gases like air and liquid also and solid also. Got it? That is why these wires will produce sound. Okay. And just a second. Okay. So I think this is clear to you. Compression and rarefaction. Student of JNV Ramnagar. Is this clear to you? Any kind of doubt in that? Please put a message in the chat box if it is clear to you. Okay, got it. Now, next is the transverse wave. We have discussed the longitudinal wave. Now it's a time to discuss transverse wave. So the basic idea I have given you, that transverse wave is nothing but a wave which is traveling, in which the particle is traveling perpendicular to the wave motion. This is the wave motion, and this is the particle motion, up and down. Okay. So wave motion, if it wave motion is left to right, the particle motion is up to down. Got it? That kind of wave is transverse wave. Now, transverse wave must have some kind of shearing strength, because if the particle is changing shape, let's say this is the string. If the shape is changing here, so we have studied in mechanical properties of solid that change of shape will caused by shearing stress. Shearing stress. Change of shape. Change of shape is caused by shearing stress. Okay. So these wave, if these wave are forming in a medium, that medium must sustain the shearing strain. Okay. But we know that in fluid, either it is liquid or air or liquid or gas, there is no concept of bearing shear strain, because if you have water and if you push the water, it will getting pushed, it will not restrain you. Okay. So that is why these transverse wave will not form in fluid. Okay. Specifically, so if you take the string inside the liquid and try to repel it down, it will repel, because the transverse wave will form in string. So it will use the medium as string. Okay. So string can sustain the shearing stress that will form. But if you want to see the water ripples that will form on the surface, they will not form inside the liquid. Okay. Got it? So I have told you that particle motion is normal to the direction of propagation of wave. Now, this one is the best example for that. Here, if you will see, if you will focus on the green dot, if you will focus on the green dot, they will moving up and down. And if you will focus on these pulses, so these are moving in this direction, left to right. So this is the direction of wave propagation, and this is the direction of particle motion. Now, as we have compression and rarefaction in longitudinal wave, same way we have crest and trough in the transverse wave. Now, I think you can guess what is the crest and what is trough. If this is a wave that we have formed by attaching a string, fixing the one end of it and moving up and down the second end, so we will get this shape. Okay. So in this particle which is at higher displacement from the mean position is termed as the crest, and the particle which is at the bottom or the minimum displacement level from mean position is termed as trough. T-R-U-G-H, trough. Okay. Now this is the transverse. So these high peak point is termed as crest, and these lower peak point are termed as trough. So I have already discussed this note that each element of the medium undergoes a shearing strain in transverse wave. So therefore, transverse wave can propagate only in those media which can sustain shearing stress, such as solid and not in fluid. Because solid is only which can restrict the change of shape, but the liquid cannot, and the air will not know. So the gas will not know. The gas will all we know that gas is not allow us or restrict us to change the shape of it. Okay. Even in the gases, if you leave it in a room, it will take the shape of room. So there is no restriction of shape in that case. So how it will produce the shearing strain? So that is why the transverse wave is not possible in gases and in liquid. Got it? Now move on to the next. This is the propagation of mechanical waves. How the mechanical waves are propagating. And in your syllabus, in this chapter, we specifically focused on the mechanical waves. Now, what are the mechanical properties, material properties responsible for the mechanical wave propagation? So first of all, if the strain is developing in the medium due to the wave motion, if the strain is developing, we have seen it that for transverse wave, the shearing strain is developed, and for longitudinal wave, what kind of strain? Compressive strain is developed. So if the strain is developing, so that material in which the wave is propagating should be elastic in nature, because if the particle, because particle is oscillating in that medium, oscillation means moving away from the mean position. If the material is not elastic enough, so the particle will be there for permanently. Okay. So for that, to avoid that situation, we will say that elasticity is the first preference for wave propagation. Okay. So that the particle can return to their mean position after being disturbed. Got it. Second is the inertia, because if you will notice down, this is the string, and if you start if you start giving a motion to it in the form of wave, So they will start like this. Got it? So in this way, you will see this particle, which is initially at this point, is traveling higher this point and also going down to this point. Not exactly it is reaching to this point. Also, it has surpassed this point and reached to the bottom one. It is because when it is at the highest point and it is coming back, it has gained enough more inertia of motion so that it can surpass this mean position or overshoot this position. So the inertia is also required so that the particle can store energy and overshoot their mean position. Now, in this way, you can see, just a second, I will explain you. If you look at this position, this particle, it is going up, then finally moving down and moving away from the mean position also. It is because of the inertia. Now, this one. This is the best image that I have seen to explaining the wave motion in terms of oscillation of each particles. So if you just consider one spring, this is the oscillation taking place. If you attach spring one to another side by side, and these all the spring vibrating at same time, so the wave will form. Okay, so you can say that a wave is the collection of oscillatory motion of number of particles, infinite particles, because in a medium there are the particles number are infinite. Okay, so you can say that a wave is nothing but the collection of oscillatory motion of different particles. So that is why, if you have covered this chapter in your school classes, that is why the wave equation is kind of written as the oscillatory equation, simple harmonic motion type. Okay. Now, so this you can say it is the transverse wave, the upper one. Okay, and the lower one is the what? Longitudinal wave. Because in this wave, the wave disturbance is traveling from right to left, or sorry, left to right, but the particle is traveling or oscillating from up and down, up to down. But if you talk about this one, the wave disturbance is also traveling from here to here, and particle is also propagating in to and fro motion form in the same direction of wave motion. Okay. Now we will discuss the basic term used. This will hardly take 1 minute. So amplitude, we have discussed in the SHM also. Amplitude is the maximum value of displacement from mean position or equilibrium position. Okay. So the amplitude of a wave is the magnitude of maximum displacement of the particles from their equilibrium position as the wave passes through them. Okay. Now, this one, this maximum value that a particle can get from the mean position is the amplitude. The wavelength is nothing but wavelength, the length of wave. Okay. So, if this is the distance between two nearest point in a wave, suppose this is the wave picture that you have. Okay, the distance between any 2 point means which are in the same phase. This one is also at the same position, this one is also at the same position. You cannot say this one because they are at the same height, so this one is also with the same position. No, it is moving down and it is moving up. This is also moving up. So that is why these particles are in same phase, not these one. Okay. Particle 1 and particle 3 are in the same phase, not particle 2. So the distance between any two points which is at same phase is termed as the wavelength. Okay. So the distance between two nearest point in a wave which are in the same phase of vibration is called wavelength. It can also be the distance between two consecutive crest and two consecutive trough or two consecutive trough. So the distance between them is also called as wavelength. Got it? Now, what is time period? So, time to complete one oscillation. So, time period T is the time a wave take to travel exactly one wavelength. In one wavelength, each and every particle will complete its one oscillation. Okay. So, time period in wave motion is the time that a wave take to travel exactly one wavelength. Okay. This one. This is the time period. But if you talk about the oscillation, the time taken to complete one vibration by a particle of the medium is also called time period. The same thing that I am discussing. What is the frequency? Frequency is the number of oscillation per second. Nu is equals to 1 by T. We have discussed it. Unit is hertz, 1 by second. Now the angular wave number or propagation constant, small k, that will also come into contrast, and it is given by 2 pi by lambda. It physically signifies that how closely packed the wave is. Okay. In a particular wavelength, how many waves are forming in there? Got it? So that will tell by the k. Look, if the lambda is high, so k will be lower, which means the wave is spreading out. The wave is spreading out. If lambda is low, then k is high. Lambda is low means wave is somehow tightly packed. Got it? So this is wave number. This formula is important. K is equals to 2 pi by lambda. Okay. Angular wave frequency omega. Omega is 2 pi by T, which is 2 pi into nu or 2 pi f. F is the frequency. What is wave speed? Wave is the speed of wave at which this wave is traveling. Okay. Or disturbance is traveling from one medium to another medium. So we know that when a crest moves one complete wavelength in one time period, capital T. Okay. So we can say the speed will be lambda by T because the crest has traveled lambda distance in time T. So velocity will be or speed will be d by T. D is lambda. So it is lambda by T. Now you can make the another formula from it. Time period you can write what? Previously we have seen this formula you can also make. Time period you have mark as 2 pi by, sorry, V is equals to F lambda, where F is the frequency. This formula is also very important. Okay. Okay. So this is it for today. I hope you have enjoyed the session. If anything is disturbing you, like any kind of doubt you have, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive. Any kind of doubt you have, you can ask. Otherwise, the lecture is being over. Thank you so much, guys. Bye-bye.